Okay, the purpose of this video is to make sure that we understand how to make a residual plot and the importance of a residual plot. And we're going to work on doing that with our calculator. Okay, so I'm going to be doing a lot of graphing calculator work with you right now and showing you kind of some cool things, how to use your graphing calculator to save you a lot of time as well. Okay, the first thing that we have is we have data below that shows the height at various ages for a group of children. So we have age, right? And then we have the height. The first thing we want to do is we want to put this into our L1 and our L2. We go to Stat, we go to Enter on Edit. We're going to clear out our L2, clear, and we're going to clear out our L1. We are going to put our ages in L1 and our height in L2. So what I want you to do is I want you to pause the video right now and do that. I'm going to do the same. Okay, ladies and gentlemen, we should have all of our data in L1 and L2 right now. The next thing we want to do is we want to find all of our predicted y's for a given x value. So if you aren't using your graphing calculator, you can go ahead and it's just going to take a little longer. You're going to take 18 and plug it in for x, okay? And that will give you your predicted. You're going to take 19 and plug it in for x, 20 and plug it in for x. But what's beautiful about the graphing calculator is we can take our cursor now and arrow up to L3 for me, okay? Arrow up to L3. Now what I'm going to do, ladies and gentlemen, okay, now what I'm going to do is I'm going to type this equation into L3 and it's going to give me all of the predicted. So watch what I'm going to do. L3 is equal to, because it's highlighted, 0.634 times x. I am not going to write x. I'm going to put times second 1. So I'll show you the buttons again, 0.634 times x. But here's the issue. These are all of my x values. So I want my list to take each one to go into the x value each time. So that's what that's doing there in place of the x. Then we need plus 64.945. And we're going to hit enter. Look at that, you guys. What this did is it just went through and it gave us all of our predicted y's. So what I want you to do right now is I want you to fill that out on your notes. I'm going to pause the video right now and do that as well. For example, when x is 18, the predicted y is 76.357. Okay, so let's do that now. Let's fill that out. Take your calculator and fill out what each one is. Okay, guys, so now we have all of our predicted. Now what we want to do is we want to find the residual for each x value. So that's the difference. That's that y minus that y hat, that predicted y. Well, if I don't have a graphing calculator at my disposal right now, I can just go ahead and subtract each one of these individually, okay? However, I have this L4 list over here that could really help us out. We know that L2 is our observed y, and L3 is our predicted y. So what I'm going to do is I'm going to highlight L4. I'm going to take second L2. So L4 is equal to my y minus my y hat. So my predicted value. So L2 minus L3. And this now all of a sudden gave us all of our residuals. Again, if you don't have your graphing calculator, you can just go ahead and you can just subtract these one by hand. But it's kind of nice that it did it all there for us. So now what we want to do is we want to write these down, okay? So pause the video at this time and write down each residual. Okay, so now what I have is I have all the residuals here, and it took me an extra second because I noticed as I started to type in, one of my residuals, or a couple of my residuals were really big and the rest were really small, right? And so what that means is I think something probably went wrong. And I noticed then that I accidentally typed a couple of these in as like 7.1 and 7.3, and I forgot the 78. So that's just a good check, a good life lesson there that, hey, you know, things gonna happen. So just be double checking your numbers. The next thing that we're gonna do, guys, is we are going to plot this as a residual plot. And I'm actually gonna show you how to do this on the graphing calculator. So on your homework, you can just sketch it and it's really nice. Okay, the first thing that we need to do, ladies and gentlemen, is we need to run a regression. Okay, so because our goal right now is to do a residual plot. That means we want to see a graph of all of my X values and the residuals that they have, meaning how far was the line off when it was predicting. So you can see this one was off. It looks like it over predicted by 0.357. This one here, it under predicted what happened. See, because it's higher than what we have. Again, we have another under prediction. It actually was 78.1, but the line predicted it to be 77.625. So we want to look at a graph of all of these X values and what their residuals are. What that's going to do, it's going to tell us, is our model appropriate to use for prediction or not? So those residuals play a very important role. So here's how you look at the plot, okay? And that's the goal. We want to know how to look at that plot. Right now, the first thing we have to do, step one, even make a new, when doing a residual plot, okay, we need to make sure we have our L1 and L2 entered. We've already done that. Step two, what we want to do, okay, step two, what we want to do is we want to now run regression. What does that mean? We're going to go to stat, we're going to arrow over to calc, and we're going to go down to number 8 like we have. This is going to give us our regression line. Stat, calc, number 8, L1, L2, go ahead and calculate. Okay, there we go. We have our regression line. Y hat is equal to 64, just like what we had. Okay, so that's step 2. Step 3, we're going to go and we're going to look at the scatter plot of our data. Okay, why are we going to do that? We want to make sure that it's straight anyways. Okay, so to look at the scatter plot, we hit second, y equals plot 1 on. Our scatter plot is ready to go, and we're going to hit zoom 9. So we have a really nice straight scatter plot there. And we came up with a line that modeled what was going on. Okay. Now what we want to do is we want to say, is this line appropriate to use for prediction or not? And I always tell this story. I could measure the height of my husband with a ruler. It could work, but is it appropriate? Or is there a better measurement tool out there? And in this case, we would, obviously it's not a ruler. We want to know, is this line appropriate to use for prediction? Or is there a better tool out there like an exponential or some sort of quadratic model, so on and so forth? There are other models. Now we will only work with the linear models, okay? So let me show you how to get that residual plot now. And you have to do steps 1 through 3 before you can get to step 4. Okay. So I'm going to go to second, y equals. I'm going to hit enter on plot 1. And then I'm going to go to my y list right here. And what I want to do, you guys, is I need to change this to what's called resid. Okay, resid. Okay, so I want to get this y list here. So I need to change it to the residuals. My X list is going to be my X axis and my Y list is going to be the residuals. So how I do that is I'm going to go second, stat, and I'm going to go all the way down to number 8. Okay. So what did I just do there? I changed my Y list here for the residual plot. I changed it to resid. How did I get there? To get to that resid again, okay, right? So I know how to get to the plot 1. We've already done that, okay? But I need to change that to resid, and how I do that again is we hit second, stat, and then you just scroll down to resid. Okay, now once we're at this screen, we can go ahead and we can look at the graph. Zoom 9. And we have our residual plot right here. So I'm going to pull this over.
So sorry.
I'm on video right now. It's okay. My daughter is clearing her throat. So sorry if you can hear that. Okay. All right. Okay, ladies and gentlemen, so we're going to look at this residual plot, and this residual plot now is telling us if we would look at, if we actually hit trace, you guys. So go ahead and hit trace right now. This is saying when X is 18, this is the residual. So this is how much the line over predicted. When X is 19, this is how much the model under predicted, and so on and so forth. Now we're going to look at this and we're going to say one thing, or not one thing. We're going to ask ourselves one question. And the question is, after looking at the residual plot, is our model, the least squares regression line, appropriate to use for prediction? And our answer is yes. Why? Because I do not see a clear pattern in this residual plot. I do not see a clear pattern. It just looks like a bunch of scatter. Well, then you're probably wondering, what does a pattern look like for a residual plot? And a pattern looks something like this, which somehow it got deleted. Give me 1 second. Okay, so I have 3 residual plots right here for you guys. The first plot, you can see there is no clear pattern. It's just scatter above this x-axis and scatter below the x-axis. But on this second plot here, we see a U. Now, it won't always look this beautiful, but this is considered a pattern in statistics, as well as this upside down U. If your residual plot has no clear shape, okay, or pattern, the least squares regression line is appropriate to use for prediction. We want scatter above and scatter below, okay? And I think the notes that I posted for you guys, those were different, but then you can still see which one has a pattern and which one doesn't. Again, no pattern means we are good to go. If there is a pattern, what you say, like plots 2 and 3 up there have a pattern. So the least squares regression line is not appropriate to use for prediction. If you're thinking like, what did we all just do? Okay, just to sum it up, what we did is we had some data, right? And you can see something's messed up with my computer because the screen's already gone. But we had this data, and you can see it at least over here in the L1. We had a regression line, okay? We plugged L1 and L2 in. Then what we did is we used that regression line and we took each X value and we plugged it into the formula, either by hand or using the graphing calculator like I taught you, and we got the predicted Y. You can see there's a discrepancy between what actually happened and what was predicted. Those are called our residuals, the difference between the observed and the predicted. So what does that tell us then? Well, we can plot our X values and our residuals on the Y axis, which is what I showed you how to do right here. And we can look and see if there's a pattern. And that tells us if this model is appropriate to use for prediction, or is there something better out there? Okay. Again, what would be better? An exponential model, a logarithmic model. There are a lot of other kinds of models that we can generate, but we want a linear model. We want a linear model. So that was the goal of this video. We will see you back in class in a second to answer any questions.